find something of value.
A higher education community in South Africa and the unintellectualization.
How central this humanity is.
Welcome to The Academic Citizen. I'm your host, Mahita Ikani, who was lucky enough to spend 33 nights on the SA Agulhas 2 in April and May of 2025 as the only member of the team for the South African National Antarctic Programme's Artist Writers Project. If you haven't listened to the first 3 episodes in this season, please do. You'll find out all sorts of juicy details about the scientific instruments on the ship, the geological formation of Marion Island, the plants, birds, seals, orcas, penguins, weevils. Honestly, if you're into cool tech, wild nature and animals, and a lot of really nice people, there is so much to explore. When I got the permit to join the voyage, I went to the Department of Forestry, Fisheries and Environment warehouse at the V&A waterfront in Cape Town to collect my PPE, personal protective equipment, for the voyage. Stuff that would keep me warm and dry in the extreme weather in the Southern Ocean. I was issued with some base layers and warm gloves that I could keep, which I love, and I'm probably going to keep forever. And also a really nice thick polar fleece, which I'll be honest, I still kind of miss because I had to give it back. And also a set of waterproof outerwear that I also had to give back at the end of the voyage. And that bright blue weatherproof jacket had a badge of the South African flag on its sleeve.
When we overwinter, we get given the jackets by DFB with the South African flag.
And I keep it.
And I just see all those photos, and so many of the team photos up on the walls at base have the South African flag. It really is a truly proudly South African moment.
Getting to borrow that windbreaker and putting it on and zipping it up every time I went out onto deck to look at birds or feel the rain on my face or just soak up the vastness of the Southern Ocean. I felt so proud to have that badge on my arm. South Africa owns these 2 special islands and this extra special scientific vessel that allows us to do research that contributes in very important ways to understandings of our planet.
South Africa doesn't have to stand back to the rest of the world when it comes to science at sea. We've got the equipment, we've got the knowledge, we've got the vessel to do that. And we've published many papers in international journals using data coming from our research vessels.
It's unstoppable. We've been collecting it for many years.
And just as importantly, these assets, because they are assets, national assets, allow our very own brilliant minds to get valuable experience in the doing of scientific work. For example, Eleanor Vederman, you met her in episode 2, where she was telling us about the birding work she did during her year in Marion, is currently doing her PhD with Nelson Mandela University on the conservation of the African penguin.
Sure, it's one of the most important programs in South Africa for field biologists or ecologists in general, conservation biologists. Yeah, you learn so much.
I mean, we're the only African country that has a research vessel like the one we're on now, that has 2 stations on islands and a station in Antarctica. And we are one of the original Antarctic Treaty Nation signatories.
In this season, we've talked a lot about oceanography, geology, botany, biology, and you've heard from a lot of scientists, new scientists, experienced scientists, about the work that they do. But did you know that Marion Island is also a location for space science?
So SANSA has a permanent presence on Gough and Marion Islands, as well as at Sanai in Antarctica, as well as here on the ship. But those presences are mainly to do with running of instrumentations in monitoring the near-Earth space environment. So we're very interested in a phenomenon we call space weather. Space weather is driven by activity on the sun, and we want to look at the impacts of space weather on things like technology, power systems, communication systems, navigation systems, and we do forecasting. Starting 2-3 years ago, we have the African Regional Space Weather Forecasting Center for the continent.
During the fieldwork on Marion, Dr. Michael Kosh from the South African National Space Agency and his colleagues set up an experiment designed to contribute to mapping the low-frequency radio waves of the universe.
Most ground-based space science is usually interested in high latitudes. And the reason for that is that the Earth's magnetic fields, which is roughly similar to a dipole bar magnet, they reach out into space and polar regions. So things that you can observe from the ground tend to map out along magnetic field lines into space, especially near Earth space. So in addition to the normal monitoring and the normal handover and the normal servicing of equipment and data gathering and all the rest of it, on this specific voyage, we did a trial of the so-called ALPHA experiment, which stands for African Low Frequency Array.
So their experiment was set up to detect low-frequency signals coming from outside the ionosphere of our planet.
That is to say, the Milky Way galaxy and the background universe, and make a map of the sky in radio space at very low frequencies.
A task that is much easier to do from a very remote location on Earth, like Marion Island, or the Antarctic, which is where they are headed for the next chapter of their experiment.
So the experiment consists of 4 identical stations, which should ideally be placed in an equilateral triangle, with one station in the middle. So when we were running it out in Carnarvon, we used a 4-wheel drive bucky and we just drove around some guy's farm. When we did it at Sutherland, which was in January of this year, we were at the South African Astronomical Observatory and we used their internal road network. So you see where the roads go, and then you try to find the triangle that will fit the best. The bigger the triangle, the better. So Marion was roughly the same. We tried to find the biggest triangle we could manage using the existing paths to existing locations. So all the stations were on existing paths. The difficulty being at Marion is that there's no vehicular transport. So now you have to carry everything by hand. And because we're looking for something that's ultra quiet in terms of electronics and electronic noise, everything's battery operated.
They did successfully gather a load of data, so much that they need a supercomputer to analyze it.
So the computer, the receiver, is powered by a massive battery. In our case, these batteries weigh 25 kilograms each, and we had to literally haul them out in rucksacks across the Maya to each location. So then it's a question of how far can you get? So we used a triangle with a roughly 1 kilometer side. So based on the paths, based on what we could achieve, and getting the geometry we needed, that's what we did. So we were in zone 1, obviously inland from the base, and we had the stations running out there. And the battery will last 3 or 4 days. So after 3 or 4 days, you have to go out there, haul the battery back to base, charge it, haul it back out there again, and restart the experiment. And because it's an array of 4 stations, the experiment only works when all 4 stations are running. So it's no point having one station running and one station off. You've got to have all 4 running simultaneously. So that meant on the days we were hauling batteries, there was a lot of running around.
If you want to find out more about this project and its next steps, which, as I mentioned, involve going to Antarctica and also the moon, seriously, check out the South African National Space Agency website. We'll put the link in the show notes. For now, let's turn our attention back to Earth. Everything is connected, after all. The Earth is just one part of that huger universe that we are seeking to understand. The SA Agulhas 2 and Marion Island are both special training grounds for the next generation of scientists.
The people going down are often very young, and this is often their first job, first time really in the field. Yeah, it teaches you so much stamina and to think on your feet. And part of that is it is very important to get people in for takeover to actually train the people, because it is super intimidating.
If you've already listened to the first 3 episodes of this season, you will have heard the voices of many young scientists who are either on their way to or from Marion for a year of field work, as well as students working on the ship as assistants to the oceanographic team. These experiences are the foundation to their future careers.
The marine science is not for biologists only. There's engineering involved, there's space physics, there's weather services, there's engineering, combined with biology, combined with physics to answer these questions. So my biggest things that I promote is collaboration, coordination, and allowing a friendly, respectful space which allow everyone to contribute towards a common goal.
Many scientists come back from Marion with skills and resources that really serve them well as they go on to do much more complex and important scientific work.
So after I overwintered on Marion, I came back and worked for 2 years at an NGO called BirdLife South Africa. And a lot of my work was looking at the effects of commercial fisheries on African penguins. And what is very apparent is that the African penguin is going extinct at a very rapid rate.
Those are our very own cuties that live at Boulders Beach and Betty's Bay, as well as a couple of other key sites on the South African coastline. And they're very endangered.
2035 is the new extinction prediction. 10 years from now, which is crazy. One of the major drivers of that is overfishing of sardine and anchovy around the breeding colonies. The controversial part is that most of the fish that gets caught is not even for human consumption. It actually gets ground up to make fish meal.
Though African penguins don't live on Marion Island, Eleanor's time on the island set her up for doing this really important PhD research on African penguins. On this specific voyage, one of her tasks is to help train the next generation of birders. She tells us what this entails.
On Marion, it's a lot of blood, sweat, and tears. It's a lot. And it kind of depends on what questions you're asking. So, as an example, every 2 weeks throughout the year, I had to do what we called our census. So I did a north census, which was from base to King Penguin, and then the south census the next day, which was base to Bullard. And you basically walk a massive circle, which is, I think it was over 20 Ks, the first one, and the other one was about 16 Ks. And you just count the number of scavengers that you see, you note down what they're doing, where they're feeding, that kind of stuff, so you can gather a lot of information. So are they feeding in the salt spray vegetation? Are they feeding in a penguin colony? And because you do that throughout the year, and then the next team and the next team and the next team does the same thing, you can see variation over time and over seasons as well. So that was really hard work. And counting paddies in between 100,000 king penguins is not the most fun I've ever had, but I was quite glad when that last census was done. So, for example, one of the other ways we collected data was deploying the GPS loggers. So these were specifically on skuas when they had small chicks. So you would catch the adult and then you take various measurements.
You make it sound so easy. How do you catch a skua?
It's not that easy, actually.
It's quite an agile,
super agile
creature from what I've seen.
And super intelligent. So once you've used one method to catch them, you can't use the same method because they know what's coming. So what we would do is, at first, we would actually just catch them by hand. So they're extremely territorial and quite aggressive. So if they see you coming towards the nest, they will come up to you, and then you can quickly grab them and restrain them. But then when we were retrieving the GPSs, because you have to get the logger back, then we'd use a long noose with like a hook at the end that goes around the back of the head. And then you can quickly pull them in. And you keep them handling to a minimum so you don't want to obviously damage the bird or anything. So you have 10 minutes max to get all your measurements. We took a whole lot of disease swabs, blood samples to look at disease ecology, isotope ecology. Yeah, and the idea of the GPS tracks was to see how the birds are moving around the island, where they're spending most of their time. And we did it on birds that were specializing on feeding on penguins versus birds that were specializing in feeding on burrowing petrels. So yeah, the takeover period is very important for that in terms of the transfer of skills. Protecting yourself against the elements, being safe in the field, all of that kind of stuff was super important to teach them. And also bird handling was a big one. So a lot of people come, and me included when I came, I didn't have much bird handling experience. So it's really important to teach people how to work with especially large albatrosses.
Here's Dr. Azrianewu Makado again. Remember him? He started his career 25 years ago as a field assistant on Marion Island. And now he is a chief scientist with the Department of Forestry, Fisheries and the Environment. He reminds us of the crucial work of training future generations of scientists. And who knows what important things they will discover.
I mean, you look at the amount of research being done there. We used Marion Island as a natural lab, which provide both understanding of doing natural research, but also developing and grinding knowledge and infusing that knowledge to the new generation that is coming through.
South African research plays an important role in the global community of Antarctic and sub-Antarctic science.
It helps us to understand the ecosystem functioning and changes in the ecosystem.
And the Prince Edward Islands are an important piece of the puzzle in understanding how the ecology of the entire planet is connected.
There are some protocols and methods that are specifically designed to answer questions that are internationally or globally questions, which we follow when we're collecting those data. We report to CAMELA, which is the Commission for the Conservation of Antarctic Marine Living Resources, that South Africa has been party to. They are founder members of CAMELA, and we are also founder members for ICAP, which is Agreement for Conservation of Albatross and Petrels.
These international protocols are crucial tools for global cooperation to protect vulnerable species and to respond to the ongoing challenges of climate change.
Every year we submit the data from different parameters that we're collecting on the islands, from the diet, what they've been eating, to the population size, to rate of arrival, and so on and so on. So it's so structured in such a way we need to understand the global sort of changes of the species, be what we're monitoring, which is some of them are selected as indicator species, like macaroni penguins, like dephis.
From the ongoing observations and data collections being done by government and university scientists on Marion Island, South Africa can contribute data to global comparative data sets so that a fuller picture can be built up of what's happening ecologically in the sub-Antarctic, and by extension, the whole planet.
We need to understand what exactly is happening in the Southern Ocean, in the sub-Antarctic region. Can the data that we've been collecting for years address different topics that we want to address, which is a connectivity, forecasting, and climate change, the integrated environment, integrated ecosystem, identify area that requires protections, because we're not necessarily looking at the predators only data, but looking at those features at sea which are more important, that assist in connecting this whole sub-Antarctic region.
It just shows how important it is to invest in scientific capacity and research personnel here at home in South Africa.
Knowledge is powerful. The interest is there, and I think the good thing that the department is doing by exposing this program more and more, having these open days when you tend to find a lot of kids asking those questions. How do I get involved? How do I become a marine scientist? How do I also go and explore that very cold environment?
One thing that should be clear by now is that there are many, many, many areas of scientific research that are involved in this bigger collaborative project.
For us to understand the ecosystem change, we start there, where it's not polluted, there's less interactions. When you're understanding how that ecosystem is responding to events to protect those species that are breeding here, that are spawning here in South Africa, and compare those two, you easily can come up with some mitigation measures that will fit here because we have understood well what happened there.
So let's hear then from two ocean chemists who are on this voyage to gather data about how the ocean in this part of the world is absorbing carbon.
My name is Muchuchu Tsawani. I work for DFFE. I look at the carbon and chemistry in the ocean. As you know, to produce electricity, we have to release a lot of carbon dioxide, and the ocean is playing a big role in taking up all that CO2 from the atmosphere, minimizing global warming. But at the same time, the CO2 that goes into the ocean is changing the chemistry of the ocean. In the main, the carbon and chemistry is affected. The main problem is the pH. that is changing. So we have to monitor such changes to see what is the distribution across the different parts of the oceans, and also how is that changing with time.
I'm Dr. Tatum Jale. I'm a specialist in the Ocean and Coast Research Group within the FFE. In a big picture, our role coming here is to understand the impact of climate change. So on this cruise, the Marion cruise, we have been doing long-term monitoring. So every year, this time of the year, we come here, we collect the data set to understand the changes that are happening on the ocean chemistry.
This is a crucial piece of the puzzle to understanding the effects of climate change and to figure out the best plans to put in place to mitigate the harm that it will do and is doing.
Recently, there's been meetings, COP this, COP that, and the different nations and leaders and top scientists coming together to try to understand and find a way to reduce global warming. But the issue here is that what kind of mitigation measures can all of us together come up with to reduce global warming? So in the ocean space, we're also trying to find ways to contribute. And we can't do that if we do not understand the role that the ocean is playing in regulating the atmospheric carbon dioxide, which is responsible for global warming. But how do we know that if we don't have data?
Let's take a second to just consider the importance of longitudinal data sets.
One single data point doesn't tell you
Doesn't
much.
tell you much.
So you need not even 5 years or 10 years data to see trends. And remember that we are talking about very small changes that happens in a short period of time. For you to detect changes, you will have to have long-term data. And the importance of long-term data is that you start eliminating the noise due to the seasonal variability, due to, there could be in the ocean, these things like eddies, rapidly changing the behavior of that environment, creating a lot of background noise. So if you have short-term data, you don't pick up trends. But the longer data sets you have, you start picking up a trend.
Every year since 2012, when the SA Agulhas 2 was commissioned, has taken voyages to the same sites in the ocean and collected data from seawater and air, adding these to this really big growing data set.
We've got these variables that are very important, nutrients, oxygen, chlorophyll, temperature, salinity. So in order to understand how are they changing, you need to conduct a monitoring line. So on this cruise, we've got underway PCO2 that measures the exchange of CO2 from the atmosphere to the ocean. We also collect seawater samples for different EOVs, nutrients, oxygen, chlorophyll from the CTD in the water column. For modelers to have future predictions, they need observations. Observations in a way that the measurements that we collect here, they use them to fine-tune the modeling so that they can predict future. For example, with modeling, they can say, okay, if we reduce the atmospheric CO2 by this much, in future this will happen. If we increase maybe pH by this much, in future the ocean will be like this, So the data that we collect here, the observations, they play a very important role. Because modeling, you can set it up and you just tweak it, but you need the real values so that when you assimilate your modeling, you've got a background of like, okay, I know how much a concentration of nutrients are there in the ocean. How are they changing?
So just in summary, we're measuring CO2 from the seawater underway. So with the instrument, it's in the lab. However, we have a water intake, which takes water from surface as the ship is moving, pumps that water into the lab continuously. So we're doing that in the seawater and also in the atmosphere. So we do a lot of measurements. I think it's about 2 hours of seawater measurements. Then we take some few data points. There's a scoop somewhere in front of the bridge that brings in atmospheric air into the instrument, that air, because it's also wet. When we are done with the analysis, we've got the data. The first thing is to do is our own, as a scientist, to write up our papers, of course. And the second thing is also to advise our managers.
This dataset feeds into government policy, decision-making, and even international negotiations about climate change and policy making. All the ocean chemistry data collected is stored on MIMS, that open source database that we've mentioned before, the Marine Information Management System.
Yeah, means marine integrated marine what.
Check out the show notes for the link. Other scientists and students can access this data and use it for their own analyses and studies.
We also use this to train others. We
Yes.
were interested in this field, students. We also assist the universities with giving them this as projects for students to do practical projects. The experience of students coming on board and doing this with us and taking the data and writing up their thesis.
That's human capital development.
Yes.
These ocean chemists have a special relationship with the ocean. They don't just see it as a place to go for a swim or as a pretty view. They kind of see the matrix behind the water. They see all of the compounds and components that make it up.
As scientists, we see ocean as knowledge. We see ocean as information. We see ocean as a determinant for our future.
Chatting to scientists is always fun for me as someone who is trained in the social sciences and humanities. I mean, my PhD is in media and communication studies, because it offers us ways to think about how all of our forms of knowledge are connected and interrelated. But the one thing that really impressed me, the more I spoke with scientists on the Marion 2025 voyage, was how committed they all are to science as an intergenerational project.
Like, my data has been collected since 2013. That's when it started. But there's no way that I would have been able to collect that myself. I would have been 12 years old. And you can imagine like how long that's taken to build up that data set, which is actually so impressive.
In the social sciences and humanities, although we often co-author and collaborate, and of course we always cite our sources that help us to build our ideas, knowledge production is sometimes seen a little bit as an individual pursuit. We each find our own topics, gather our own data for our questions and, write them up more or less on our own. But when it comes to longitudinal data collection, scientists are always analyzing data collected by people before them and collecting data for others who will come later so they can analyze it. Sarah, that master student mapping zooplankton, has also been analyzing a load of data collected by other scientists in the past.
I can now, more than 10 years later, look at it for the first time. Nobody else has looked at it yet, which is kind of madness. But they've done this for the last decade with the hopes that somebody in the future, some 12-year-old at the time, would come along in the future and have a look at the data for them.
These super rich and growing, unstoppable, longitudinal data sets are a valuable resource for teaching, learning, research, and analysis. And they're open source. They belong to everybody, not just the scientists taking the current set of readings or samples. From the ocean physics and chemistry to the biological biodiversity, all the zoological, chemical, oceanographic data that is collected feeds into a much bigger scientific project. How can we protect this planet and all the creatures that live in it, including human beings? We can't do that job without understanding how everything works and how it fits together. For example, Emma hopes that her research about fin whale vocalization can help to feed into policy that can regulate the amount of ocean traffic noise that will impact whales negatively.
Hopefully to influence some policy or whatever to decrease the speed at which vessels are allowed to travel in certain areas. If it is a space in which animals travel to and in which they are vulnerable, it's a space that should be protected. And it's kind of the same around Prince Edward. Like, the animals use the islands for specific reasons. Making sure that these spaces stay safe for those animals to come back to is very important.
The ocean is connected all over the planet. Although we give different sections different names, it is ultimately just one body of salt water. And the oceans are also connected to the atmosphere through gaseous absorption and exchange. And the oceans are also connected to the land and all of the species living both on that land and in its waters.
One of the coolest things about plankton is that, they live on a completely different scale to the rest of us. They are just tiny little microscopic things drifting in the ocean, and they have no idea that any of this exists. they don't even know what the ocean is. They're just in it, you know,
Trying to survive.
just trying to survive. And they're all interacting with each other in their own little like unique ecosystems. And yeah, it's just like something we can't even see. And it's all around us. And yeah, plankton obviously form a part of the food chain. So they're a pretty important part to look at.
Very important part of the food chain.
From the tiniest microbes to the massive charismatic creatures, all are under major threat from climate change.
Biology and marine biology and oceanography at this point is trying to find ways to mitigate global change damage.
And also trying to understand how it is going to change. For example, if the plankton community is shifting over time, if we are going to see a decline in the size of the plankton that we find here, you might have a huge loss of biodiversity on the islands itself. And this is the only place on Earth where these organisms can nest and where they can breed.
So how can we build awareness about the problem? Here's Dr. Zimkita Gebe. Remember her? She studies the tiny glowing phytoplankton using cell count technology.
I just did an open day to the community in East London a few months ago, where they were asking, so how do we make sure that we fix things? How do we reverse everything? And I said, the only way to reverse these things is to leave the oceans alone, close some systems for a little bit, open them after a while, because there's no coming back and putting medicine in the water to change things. If you give it a little bit of time and you take care, the ocean life is going to give us more than we actually deserve, I would say.
That's all we have to do. Take care of the ocean. Allow it to regenerate, and it will continue to give us oxygen and food for generations to come. A lot of what we've heard about in this special season of the podcast has been about the research work being done to understand and, by extension, protect the Prince Edward Islands. Make no mistake, it is a huge privilege to be able to go and do research work on Marion Island. Each year, scientists vie for the opportunity to get berths on the ship, to send themselves, their collaborators, and/or their students to collect data and get valuable experience in fieldwork. Because the Prince Edward Islands are special nature reserves, people can only visit once they have applied for and been granted permits to do so by the government department responsible for the islands. The fact that I got to join the Marion Relief Voyage 2025 as part of the Artists and Writers program is a huge deal. In 2024, the AWP sent Adrian van Eerden Wharton, a visual artist who works with oceans, islands, and seawater. Next year, we hope another artist or writer can go, and the year after that, and the year after that. Including communicators, podcasters, creative writers, visual artists in the research work that is being done in the sub-Antarctic and Antarctic is important because it can bring new life to the science that is being done there and new perspectives. And it can also create new affective and emotional connections to the region. And these are equally important in developing knowledge about the polar regions and a kind of general public regard and care for the work that's being done there. Everything is connected.
It is always important to understand our planet, but also on a larger scale, you might want to compare Earth with other planets in the solar system. And by knowing what's going on in the interior of the Earth also help us to understand how planet Mars formed, how the Moon formed, the planet Venus, and so put that into a global perspective of how the solar system formed and evolved till now.
Another thing that all the scientists I spoke to have in common is curiosity. They are driven by genuine interest in the world around them and how it works. And they're all fired up by figuring out new ways to decode and map the wonders of the universe.
We should not be frightened of the unknown or thinking, oh, I can't think of an application for doing this. Because we know that stuff you're doing now will suddenly prove to be very useful unexpectedly 50 years in the future. But that's beyond a normal career. So you're doing it now so that somebody else can step on your shoulders and do something useful. Just like I have and others have for our predecessors, you know.
Who knows what the next generation of researchers will discover? It's really hard to sum up the huge breadth and depth of the scientific work being done by just the collection of scientists who appear on this podcast season. And I didn't manage to record with everyone on the ship, maybe about half of them at most.
That is a really hard thing to communicate to people back home who've maybe never been to sea. But once you've been on this ship, you've been sailing for, 4, 5, 6 days. There's nothing out here except water. And then suddenly these massive islands pop out of the ocean. And I mean, they are such an important breeding ground for all these incredible, unique species. And I really, I wish and I hope that Marion and Prince Edward Island will become part of the South African heritage, and for people to give them the value that they deserve.
So what you've heard in the past 4 episodes is just a snippet of insight into a really rich and fascinating world, sub-Antarctic science from the South African perspective. I felt a mix of huge joy at getting back to land, seeing the familiar shore of the Durban promenade, the palm trees, feeling the warm air of KwaZulu-Natal, and also sadness at saying goodbye to this big red ship that had become my temporary home. I had handed back my blue, proudly South African windbreaker and packed up my microphone and notebooks into my kit bag. I said goodbye to everyone whose company I had shared for over a month. I lugged my stuff down the gangway, called an Uber to take me to the airport to fly me home. Most likely, I'll never get to go back to Marion Island or take another voyage on the SA Agulhas 2. But I really hope that other writers, poets, and artists do, to join that scientific community and bring their own unique forms of knowledge creation into the mix. This podcast was created, recorded, and produced by me, Mahita Ikani, with fabulous production assistance from Andrew Burnett, who also did all of the sound editing and sound design. My berth on the SA Agulhas 2 for the 2025 Marion Relief Voyage was provided by the Artist Writers Project for the South African National Antarctic Program. The Artist Writers Project is directed by Professor Sean Lavery and Professor Jean Brunrit, and I'm so grateful to both of them for trusting me with this really special experience. Big thank you also to Adrienne van Eeren-Wharton for helping me get prepped. She was the artist in residence in 2024. A warm thank you to all the guests who appear on this episode. Dr. Michael Kosh from the South African National Space Agency, Dr. Zimkita Gebe and Dr. Azvianewu Makado, Dr. Tatum Chali and Muchuchu Tsanwani from the Department of Forestry, Fisheries and the Environment, Eleanor Weidemann, Professor Guillaume Delpech from the Université Paris-Saclay, Marcel Vandenberg, Emma Swanepoel and Sarah Dupré, MSc students from UCT. The production of this podcast was funded by the South African Research Chair in Science Communication, which is supported and funded by the South African National Research Foundation. I am the chairholder of the Saatchi in Science Communication. The distribution and marketing of The Academic Citizen is done by Fumani Dwara. Massive thank yous to the captain, officers, and crew of the SA Agulhas 2 for everything, keeping us all safe and well, for cooking our food, for making the ship work, and for all of the chats at the bar. I also want to say a special thank you to my cabin mate, Yolanda Hansraj, who was really the best roomie anyone could ask for on a voyage like this. To find out more about the South African National Antarctic Program, the SA Agulhas 2, and the Prince Edward Islands, check out www.sanap.ac.za. Please note that the voices of the scientists included in this season share only their personal views and experiences. This podcast and everyone in it does not represent the official viewpoint of any of the organizations mentioned or linked.